All right, 1, 2. All right, welcome to this session, HTTP2 for the web developer. So during this session, very short session, I'll try to explain the very core basics of HTTP2 and what they mean for us as web developers. So very quickly, I'm Brian. I'm working on the Spring framework, and since I only got 15 minutes to cover a lot, so let's get started. So if you only have to know one thing about HTTP2, is that it's all about solving latency issues. HTTP 1.1 has some of those issues, and we've been tackling those with workarounds in some ways, but HTTP2 is about solving most of those. And if you want to understand how it's solving them, then you have to learn the very basics of HTTP2, and that's what we'll do in more or less 5 minutes. So 6 steps to really understand what HTTP2 is doing and how it is solving those latency issues. Number 1, in HTTP2 you only have one single TCP connection. It means that you don't have many, obviously, but it also means that you're spending less time doing TCP handshakes, you're spending less time in slow start and in the initial congestion window in TCP. So basically you're trying to get the most out of your link as soon as possible and to maximize the throughput for your application. With that link, you have multiple streams. It means that instead of having several TCP connections and doing things over several connections, you only have one, but then you have multiple streams over a single TCP connection. It means that you can send and receive multiple messages interleaved, cut into pieces on the same TCP connection. And unlike HTTP 1.1, you don't have the head of line blocking problem, meaning you don't have to receive the responses in the same order you send the requests. So that's something new as well, interleaved multiple streams. And like we said, so since those messages are cut into pieces, they're cut into frames, binary frames. So the HTTP2 spec defines several types of frames. You've got headers frames, you've got data frames, all binary. So it means that the messages are cut into pieces and can come in several parts, interleaved with other messages. And it also means that you can't really rely anymore on tools like Netcat, writing HTTP protocol by hand over a socket. It's not happening anymore. Even for your tools, since it's binary, you need specific tools to get access to what's going on the wire. So to really see what's going on, imagine this is your single TCP connection between the server and the client. And imagine the client is sending a request. So for this, you can just send a headers frame and asking for the /Java resource. Notice that there's an ID, a stream ID, because a given request response exchange is a given stream. So you're asking for that Java resource, and at the same time you can just post a new resource, that Devoxx resource. And since it's a post, you can send another frame, since this time a data frame. So you're sending some more data. And at that point, the server can start responding with a headers response for the first request you made. So this time, just headers. And then the server can continue responding with this time some data for the response, for the first response. And then at some point, maybe the client can send some more, right? Because it's all interleaved, single TCP connection, multiplexed. So everything can happen like this at any time. And then the server can go on and respond for the second. So that's how things go, exchanging frames over the wire, back and forth with the server, between server and client. But there's something more, because number 4 is about flow control. Flow control means, just like a bit TCP, if you know how TCP is going, the client and server can negotiate window size, frame size, and how much they are willing to receive and take for messages. So it means that the server and the client can more or less control how much data they can get and how much request they can accept. So that's a new mechanism. There's also HPACK. So HPACK is a spec on its own. It's a separate spec, quite dense actually. HPACK is all about saving space and not sending and receiving all the time the HTTP headers. Because with HTTP 1.1, you're always sending add-on user agent, accept, etc. You're always sending the same information sometimes, a lot of duplication. So HPACK is all about it's all about not sending them over and over again by sharing some kind of state between the client and the server, and with some kind of common understanding of those are the common headers we're sending and receiving, its common values. So in the end, it's all about having some flags and very little data sent over with the headers frames, which are, in this case, very minimal. So saving space and not sending over and over the same data. And for the last one, TLS is not, or it is required. Actually, if you look at the spec, H2, the HTTP2 protocol, requires TLS. So that's good news for our users, right? Everything encrypted, privacy, very good. But there's another variant of that protocol which is called H2C. Both are specified, but many vendors, explicitly the browser vendors, they don't intend to implement the H2C. So H2 encrypted TLS for most of your needs. Another thing that you can look into is that H2, because it's relying on TLS, so you set up the TLS connection, the encrypted link, and then you negotiate with the server, the protocol you'll be using, so in this case HTTP2. If you were to use H2C, it's a bit like negotiating WebSocket with the server. You have to use the HTTP 1.1 upgrade mechanism to tell, okay, I'm going to use HTTP2 as a protocol, and we all know that for WebSockets, it's creating some issues negotiating a different protocol over the port 80. So many services think that, oh, okay, this is HTTP 1.1, and this is not the case. So anyway, that's the basics. If you want to try a couple of things and really know what's going on, you can go to that example. It's a Spring Boot application with Jetty, HTTP2, and you can try things out. But right now, the good questions. How should we adapt as web developers? What can we do? We already heard that some of the front-end optimization we've been using won't be good enough. Like concatenation, it will waste bandwidth and it won't work properly with caching. So concatenation should be out of the question here. But we should keep gzipping content, we should keep e-tags, cache control, and we should probably look into JavaScript module loading, because this time sending and receiving new requests are less expensive here. So modularizing our code the way we're doing on the server, on the client, probably a good idea. But at that point, you may think, okay, I've heard about those new HTTP2 features. I heard they're really great. And you're right. There's HTTP2 server push. Server push is a new, and I insist, optional feature of HTTP2. The server can now push responses before the client even asks for those. So usually what people tend to say or think at that point is, okay, I know what I'm going to do. Whenever a client asks for a page, I'm going to push all the static resources to the client, JS, JavaScript, CSS, etc. That will really improve the page load time, because the client won't even have to parse the page and ask for those resources. I know what's going on. I'll push them. While it may be a good idea, in some cases it can be tricky. Like, if we're back to our server and client case, let's say we want to, the client asks for that particular index.html page. Then the server, instead of sending a response, a headers frame with the response, this time we're sending a special type, a push promise. So we're saying, okay, for the stream 3, I'll send a stream number 8 with this time that corresponds to the main.css. If you were to send that request, I'll respond that. And that's what I'm going to push. So I'm pushing this, then the headers of that response, and then the data, etc. And then also I'm sending that script, etc. But if the client already has those resources in cache, then the client has to go, nope, I don't want those, reset stream. It's canceling, it's telling to the server, I don't want those resources, I already have them. So reset, again and again. So if you imagine with your clients already having those resources in cache, instead of making your application faster, you'll start pushing a lot of resources, and your clients will go, I don't want them, I don't want them. And meanwhile, you're not sending the actual HTML page. You're not sending the important data to your clients. So instead of making your page load time better, you may be hurting it in a way. So you may think, why we're not sending the HTML page first, right? Here, we can just send some bits of the HTML page and then push those resources because we know it'll be useful. But if you do that, it's actually warned against in the spec. They're saying this, basically, you shouldn't respond. You shouldn't respond first and then push promises, because in this case you may run into some kind of race condition, and that's the kind of case you run into, right? Again, the client asked for this. Let's give him what he wants: headers and data for that particular index.html page. Then the browser is actually parsing HTML. Okay, discovering I need to ask for this JS, I need to ask for that CSS. And in that case, if you're pushing promises after the fact, then at the same time the client may ask, I want this. What's going on here? What should we do? Right? It's some kind of race condition. It's not really effective. It's warned against in the spec. So really, what should we do then? Because server-side application, we know about the structure, we know about the number of size of the resources, but the client at the same time, only the browsers know better about the heuristics, what it needs to render the page efficiently. It knows what it's got into its cache, etc. Or us, maybe we know better, right? Obviously, there's another new feature in HTTP2, this time also optional, and this time it's all about the possibility for the client to communicate those needs. So instead of sending just dumb requests, the client can tell, okay, for this image depends on that other resource, and I'm putting a weight on it. So a way for the client to communicate some kind of tree of dependencies to the server, and so the server can allocate like network bandwidth or CPU, let's say, resources to give those resources as soon as possible to the client and as efficiently as possible. So actually using this, the experience showed that using this feature properly, both on the client and the server, is a huge performance boost. And that's really one of the keys here. So the response here, as usual, no silver bullet. You don't have a perfect response for everything. I guess one of the best advice I'd give you is to use your browser developer tools and all the tools you can have, and try your application in a real-world environment as much as you can. Because, for example, with the recent developer tools, you can look up in the network tab. You can see the graph of resources being downloaded. You can see if it's HTTP2 or not, and you can even say, okay, I want to simulate that connection over a 3G. Because local or very good network and 3G or even worse, edge, it's very different. And it makes a lot of difference over HTTP2, even more. So I'd argue, if you want to test things out, just start with HTTP2. There are ways to start testing things with HTTP2 or the JVM. Support is coming. And if you want to choose properly an implementation, I can give you some tips. So if you want to really choose an implementation, those are the items you should look for. For example, I want a container or a serverless environment that, or whatever web that serves using HTTP2. You want to look what kind of I/O and programming model is it using under the cover, threading or event loop, etc., just to know how it goes. If the TLS support is decent enough and complete enough, because that's really important with HTTP2. You don't just throw any TLS support. It's got really strict requirements. You need to know, does it support server push and stream prioritization, just like we talked about? Because the way it's supported is really important. What kind of primitives and API is it providing to you? Because obviously, if it's only pushing everything first, then not flexible enough, right? And also, if it's reactive streams friendly, you may look into that thing. You can see some kind of mechanical sympathy between reactive streams and the flow control feature of HTTP2. So in a way, you could really control the back pressure from the client to the server, even over the network. So really interesting things to look into here. I'm all done. We're 15 minutes here in. Thank you.